Hello everyone. In this video I will implement vector database to save and fetch the embeddings from the database. There are various vector databases in the market like Pinecode, Waviate, even MongoDB has vector database option. In this video I'll use ChromaDB. It provides file-based implementation like SQLite, which is good for this example. So to save our embeddings to the vector DB, first we need a database client. So we'll create a database client first. So we'll import the ChromaDB. Then we'll create a client ChromaDB dot persistent client, and we'll provide the path, root path. So at this path we will create the database file and then create this client. We'll have the collection table name, let's keep it knowledge base. Okay, and then we'll use this client. So client ChromaDB client has this get or create collection method. Will provide the collection name. If there is a collection already in the database, it will fetch it, otherwise it will create and fetch it. And then we will use this collection and add the embeddings. So you can see for each embedding it will create IDs and it will store the embeddings in embeddings field. We also need to store the original document for reference purposes. So both the fields are stored, documents and embeddings, and here we have knowledge base embeddings, right? So we'll change this method and also accept here knowledge base and store that knowledge base in documents and the embeddings in embeddings. Okay, and so we are using this here. So we have this knowledge base here, so we'll pass it. Okay, so knowledge base and knowledge base embeddings both will be passed. Collection will be created and added to that collection. Okay, and in the RAG demo you can see during the semantic search we are fetching the embeddings. We are passing this embedding for the semantic search, and after the match we want to fetch the original document. So we had this knowledge base list earlier, which we need to replace with the knowledge base from the database. Right now we don't have the knowledge base object here, so we need to fetch it from the database. As we have saved the both, we can fetch it from the database. So now we'll implement the fetch from DB. So again, client dot get collection, pass the collection name, and then collection dot get. So this get will return all the collection, all the items in that collection, and we need documents and embeddings. So it will return here, and we'll create a list and written from this method. So here we will get both the list, knowledge base and knowledge base embeddings, and then we'll use this knowledge base here. So now our program is complete. Initially we will run this knowledge base file. We will load the knowledge base txt, then convert it into vector, pass this knowledge base and the embeddings to save to vector db. We'll then create the collection and store it in the collection. So first flow will be to load the document, convert to vector and save in the database. Now our knowledge base will be ready and anyone can query that knowledge base. Then we'll run the second flow where we'll ask the question. We'll convert that question to embedding. We'll pass that embedding to semantic search. Now here semantic search method will first load all the data from the vector DB, all the embeddings and also the knowledge base. So from that knowledge base embedding, it will match this question embedding and get the results. And from that results will fetch the original content, matching content from this knowledge base, which will be here, and then we'll create the context and hence the prompts, right? So this will complete the flow from creating the knowledge base, querying in that knowledge base. Now one thing we need to modify here. If you see what we are doing here, we are fetching all the embeddings and then we are doing the semantic search. But originally this is not the way. We do the search in the database. So this semantic search, right, this method is done in the database. So basically this thing is implemented by the database. So this vector database is not just to store the vector. It basically provides this search implementation, and there that is the thing which is the advantage of the vector database. And that is where we need to learn to uh, improve the search result, how to query so we get the best match. So this vector DB collection can have millions of records. We get big files, hundreds of files. We convert them to vector, we save them to the collection. So this collection can have millions of records of embeddings. Now we have a question and we need to find a match. So we don't load all the millions of rows. We convert that question to embedding and we query in that vector DB with that embedding, and this vector DB does this search and returns us the result, right? So let's try to implement the search. Instead of fetch from the DB, what we will do is search vector DB, and it will have query. So again get the collection and then do the query in that collection. Instead of get, we'll do the query. Query will be query embeddings. Okay, so here we will have that same yeah, so here, right, so here in fetch we are not passing the embedding, we are fetching everything, and then in the semantic search, semantic matching, we are passing the embedding. But as we are doing this search in database, so we need the embeddings here. Okay, so we'll pass this embedding to the query embedding of the query method of this collection. So from the millions of records of the embeddings, it will search this embedding, it will match that embedding. It's like there are millions of record, and this uh, embedding will be matched in every record and find the best matching. And here we can pass and results 10, like pick the top 10 results. So now instead of fetch from DB, we will use search vector DB, and we'll pass this embedding. Right, now instead of this results, we'll use this results coming from the database. Okay, so the topic for further learning would be this part, learning how to query. Like if we are learning relational database, we learned a basic query, but we need to make uh, expertise in that, how to make better query. If you're learning MongoDB, we know how to save it, how to fetch it, but doing the aggregation search, uh, that is the important part. So this is the basic uh, add method, get method, and query method. But in practical application, we'll have to improve this query, so that you need to become expert at. Okay, so this completes our RAG demo. So we create the knowledge base, we save in the database, we get the question, we embed it, we query in that database instead of doing this search, and then we get the chunks from the database, we build the context, and then we create the LLM. So I'll upload this code to GitHub, you download it, go through that, try to implement this whole program, and if there is any doubt, let me know.